Let's have the hypothesis testing for two population mean independent sample. Independent samples, or also known as the unpaired, the information or data were taken from different groups. Then the number of samples may or may not be equal. Example, male and female, section 1 and section 2, control group and experimental group, elementary teachers and high school teachers, faculty and staff. So the diagram, let's say for example, you are going to give midterm exam score. Then you'll be having group A for the female, the midterm exam score of female. Then group B for male, the midterm exam of male. Meaning, you only have one test administered to two different groups. One test administered to two different groups. It can be also that the midterm exam score of section A and then section B. Or it can be the faculty, the staff. Okay, so this is the diagram for the independent samples. For parametric test for independent sample, we have the z-test for two sample means. This is being used if the research design of the study is descriptive and the sample is 30 or more. Example, do elementary teachers and high school teachers significantly differ in their professional engagement? Next is the t-test for two sample means. This is being used for experimental research design made use of less than 30 participants. Sometimes, the test is being used even if the data is 30 or more, provided that the research design is experimental. So, example, do experimental group and control group significantly differ before remediation class in Science 4? Okay, so that would be for the t-test for two sample means. We have here the different assumption. The parametric tests like the z-test and t-test are applicable when the following assumptions are met. The two samples of sizes n and respectively are taken randomly and independently from the two normal populations. The variances of the two populations where the two samples were drawn respectively are both known and assumed to be equal, and the level of measurement is at least an interval scale. The nonparametric test for independent data, the collected data is being ranked to a certain order or number. So Mann Whitney U Test function to test whether two independent groups have been drawn from the same population. Then the power efficiency is the Mann Whitney U Test is found to be the best alternative to the parametric t-test. So we are going to have the non-parametric test for independent data, which is the Mann Whitney U Test. Example, is there a significant difference in the number of episodes of shortness of breath over a week period in the random participants receiving the new drug as compared to the receiving placebo? Data are in ordinal scale and the two samples are independent. We have here the same data as what we have done last time from the previous videos, but this time we are going to have two sample means for two independent data. So we have here, is there a significant difference between the IQ of the office workers when grouped according to gender? So we have two groups of office workers, the male group and then the female group. Now the researcher wants to know if there is a significant difference between the IQ of the office workers when grouped according to gender. We know from our previous lesson that we cannot just apply a given statistical test without testing if the normality is normal. Let's start first with the formulation of the null and alternative hypothesis. So for our null hypothesis, there is no significant difference between the male and female office workers when it comes to their IQ. Then, if that is our null hypothesis, let's negate that for our alternative hypothesis. So instead of saying that there is no, we can just say there is a significant difference between the male and female office workers when it comes to their IQ. Next step, choosing the statistical test. For 2-independent mean, we have 2-sample t-test and Mann Whitney test. So in order for us to know which of the two are we going to use, we have to get the following assumption for the parametric test and then the non-parametric test. So let's go over to our data, our IQ. So first, go to Analyze, Descriptive Statistics, then click Explore. Okay, then we remove all of these. Okay, the one that we are measuring or testing is the IQ of the workers. And then, go to Statistics. That should be 95. Continue. We go to Plots. Histogram should be checked. Normality plots should be checked. Then, we click Continue. And then, we click OK. Okay, from this, we have the case processing summary for gender, the descriptives, but our concern is the test of normality here. For the male, we have 0.126, and then for the female, we have 0.098. Then we compare that to our critical value, which is 0.05. 0.126 and 0.098 is higher than 0.05. Therefore, our data is normally distributed. And this is the histogram. Okay. Since we have proven that our data is normally distributed, we all know that the test that we are going to use is the parametric test. And the parametric test for 2-independent sample is what we call as the 2-sample t-test. So we go back here. We have 2-sample t-test for independent mean. Okay? Then we go back again to our data. We are now ready to analyze. So click Analyze. You go to Compare Means, then Independent Sample t-test. Okay, so we're going to click Independent Samples t-test. Okay, we remove this first. Okay, so for our test variable, we are testing the IQ of the office workers, and then the groupings is the gender, since we want to know the difference between male and female when it comes to their IQ. Then, notice that you cannot click OK here because there's a question mark in there. Therefore, we have to define groups. So, we click Define Groups. Okay. Group 1 is 1. We all know that it's 1 because our code is 1 for male, 2 is for female. Then, after putting 1 and 2 there, we click now Continue. Okay, so there's a number already there, 1 and 2 instead of question mark a while ago. So after that one, we can now click OK. Okay, so we have here the group statistics and then the independent sample test. Okay, so notice here, we have two answers, 0.289, then 0.289. But we do not know what to get between these two. So in order for us to decide which to get between the two, even if they are the same, we go to the Levene's test. Okay, so what does Levene's test mean? For equal variance, assume we can say that the computed significant is higher than 0.05. If it's lower than 0.05, we are going to assume equal variances. Okay? But since our significance computed here is 0.641, which is higher than the 0.05 critical value, this is our answer, the one on top, 0.286. Okay? So, copy. Then we go to our data for the computation. And then we paste. Okay, so we have here. And then, since we use this 0.641 for equal variance assumed, we are going now to get this as our answer. So, 0.289. Okay, so let's make now our decision. Since the computed value is 0.289, which is higher than the critical value of 0.05, then we accept the null hypothesis. Okay? So we accepted the null hypothesis. So upon accepting the null hypothesis, we are going to have our conclusion already. There is no significant difference between the male and female office workers when it comes to their IQ. Meaning, when it comes to their IQ, they all have the same performance. Okay, for the next example, we have this problem. Is there a significant difference between the performance of the office workers after the intense training when grouped according to gender? So we are going to compare again the performance of the two groups according to gender. So let's formulate the null hypothesis. Our null hypothesis, there is no significant difference between the male and female office workers when it comes to their performance after the intense training. For the alternative hypothesis, we negate our null hypothesis to state that there is a significant difference between the male and female office workers when it comes to their performance after the intense training. So choosing the statistical test, we cannot choose yet the statistical test unless we tested it according to its normality and then the assumptions. Okay, so we are concerned to their performance after the intense training. So we go to analyze, descriptive statistics, then we go to explore. Then instead of using IQ, we are going to use their performance after this one. Okay, and then we click OK. Then we have our data already here. The test of normality is our concern. We have 0.022, then 0.001 for male and female respectively. So what does it mean? Since the significance value that were computed is less than 0.05, we can now conclude that our data is not normal. So it's not normally distributed. So look at the histogram, it shows like this. Okay, so since we have seen that the normality is not normal, we go then to its non-parametric test for two independent samples. And that is what we call as the Mann Whitney test. Okay, so we are going to use the Mann Whitney in our computation for SPSS. So we go back to our SPSS. We go to Analyze. We go to Nonparametric Test. Then Legacy Dialog. And then we click 2 independent samples. Okay, so we go to Analyze, click Nonparametric Test, Legacy Dialogs, and 2 independent samples. Okay, so we remove this first. So in here, we are going to put the performance after the intense training, and then they are going to be grouped according to sex. Notice again that we have question mark here, so we have to define the variable. Okay, so we have here 1, then 2, then continue. Okay, so we go to option. Okay, so that's okay. And then in here, Mann Whitney U should be checked. Okay, Mann Whitney U Test should be checked. Then after that one, we can now click OK. Okay, so we have here the Mann Whitney test showing that we have 10 males, we have 10 females, then we have 20 total respondents. Then the mean rank of the male and then the mean rank of the female. Now we go here to the Mann Whitney U test. Okay, so we have the significant difference of 0.516. So if that is 0.516, which is higher than the critical value of 0.05. So we copy this, then we paste it in our data for the computation. Okay, so there. The test statistics, we have 0.516 here. Okay, so from that one, we can now make our decision. Okay, for our decision, since the computed value is 0.516, which is higher than the critical value of 0.05, then we accept the null hypothesis. Okay, so upon accepting the null hypothesis, that would be our conclusion. So the conclusion for this is there is no significant difference between the male and female office workers when it comes to their performance after the intense training. Okay, so we can say that both of the genders are performing well in this kind of job that they have.